All right, coming back live here with Jermaine, Cloud Underground. How's it going today, Jermaine?
Pretty good. Yeah.
Excellent.
Warm weather, so I can't complain.
Oh, we've got snow still. It's one of those days, but it's warm weather's coming. So some things we've been working on because for those who aren't familiar with this yet, the Cloud Underground team is working to launch a service with a team called Underground Ops. Jermaine is the technical lead for Underground Ops for all of the engineering and service delivery. And so Jermaine's been working with us on building out the Underground Nexus, which is effectively, you can think of it like a cloud native server, or like it's a cloud server, but it's like a cloud native server. Maybe that's a way to put it. Or a GitOps server. For those of you who know what GitOps is, GitOps. But if for those who have been following us, you have somewhat of an idea. If you know what the cloud native landscape is, the Underground Nexus is more or less built for cloud native applications, and it generally works with things that you find on the cloud native landscape and anything else that generally works with the cloud native landscape. It is an agnostic tool. It is in beta right now, so just as we have on our website, you can find the link in the description of the stream. But you'll notice that there might be some changes, and you'll notice that there are frequent updates because we have had a number of updates lately, including the release of something called Kubernetes. So we won't be talking about Kubernetes yet because it is basically a pre-built Kubernetes cluster so that people who are just trying to work with Kubernetes, it's this resource now just has it in there already running so that you don't have to learn how to necessarily configure the whole thing from scratch. But we're not here to talk about that today because what we are going to talk about before getting into crazy things like Kubernetes is Kubernetes uses what's called load balancing because it's a cluster technology that's built for supercomputing, data centers, that sort of a thing. So for those who are used to like working on, say, like a single laptop or a single desktop, tools like Kubernetes and Docker Swarm and resources are made for if you're working with multiple servers, like if you're working at a data center. So like if you're using Facebook or you're using LinkedIn or you're using YouTube, the things that run those websites, those big servers, those big data centers, all of the tools that you generally find or use in cloud data centers of sorts require load balancing. So I guess maybe one thing that I'll ask, because Jermaine is a little newer to technologies like this, and one of the benefits of getting an explanation from someone who's newer to some of these technologies is you can come up with ways to kind of explain it to someone who hasn't been doing it for a long time. So I've been working with load balancing for a long time. So my explanation is long-winded, and I'll be like, load balancing, I'll tell you have to reverse proxies, and they have to talk to each other. Anyways, instead, I'm going to say, Jermaine, in your words, for someone who's not like from Cloudland for like 10 plus years, what is load balancing?
So, I guess for me, the best way that and I'm a very simple guy. So for anybody out there that's looking for something super techy, you're not going to get that here. Me, I'm going to tell you from my point of view, load balancing is, let's say that we have one big bucket, right? And originally all the water was stored in this bucket, and this bucket just got way too heavy, right? So what we decided to do was divvy it up into four different buckets and make sure all those buckets are balanced. So, instead of it being one big bucket with 100%, now you have all these different buckets that still have the same type of water. Let's just say it's Poland Springs, all right? And Poland Springs is now in every bucket, and it's evenly there, and it's distributed to the whole community.
It's a good comparison, especially because we actually have something in here called buckets, because we have S3 buckets, which we'll talk lightly about too. And That's a good way to put it, because if you're thinking about if you look at when people are have like the things where they're like carrying water and stuff like that, if you're trying to like haul a whole lot of water, they'll have like two separate pails where you distribute the load, because that's a lot. Otherwise, you could try to like carry all of the water like this if you're trying to just like transport some water, maybe not far enough, or like in a location where, like, if you're trying to get like well water. If anyone's ever dealt with a well, so I come from like the mountains and stuff like that, and sometimes if you're like at a cabin that doesn't have running water, you actually have to deal with that. So you'd be sitting there just like carrying your water. It's much easier to either have something you're pulling or something that distributes your load. But you want to distribute your load regardless. And with cloud, it's no different, because systems, they hit thresholds, they hit loads. If you've ever been using a single computer and it just starts getting slow and bogged down and overwhelmed and all that good stuff, then load balancing, if we take a look at this right here, it's one of the more advanced things, and we have the Underground Nexus sort of built to start doing load balancing, and we have the services built for folks to deploy right away. But load balancing is one of those things that's very custom to an environment. So because it's custom to an environment and your applications, we're instead of having like pre-built load balancing that might not even be right for you and your solution, we have the resources for you to put together things to load balance your work and your project and what you've been working on, so that you can begin to scale your work beyond one cloud node. Now, the Underground Nexus can be used as a cloud node, but it's built to work with cloud nodes of whatever sort you want to do. So you can use the Underground Nexus as a load balancer itself, or you can use it to host and then use its load balancing resources. But Traefik is a tool you can use with or without the Underground Nexus. It is a cloud native tool. If we were to take a look at the cloud native landscape, and we take a look at things, there's Traefik over here. There we go. Traefik. You don't need the Underground Nexus to work with Traefik. But if you're trying to figure out how to configure it and you've never worked with something like this, if you think what I'm about to show you is complicated, then go on over to Traefik's website and start trying to learn load balancing the direct way. We're going to give you a little bit of a head start so that it's not crazy. So if you wanted to take a look at the load balance configurations that we have, you can also use it as a template. You don't necessarily have to use it directly with the Underground Nexus. This is just a Traefik template to be used where your work needs it. And the way that we have this configured is with a middleware that's designed to allow you to actually put passwords so that you can protect your resources at scale. And I will show everyone what that looks like. And what do you mean protect your resources at scale? Or why does this matter? Why is this something that we care about? When you're working with supercomputers and you're working with different things, if you don't have like, say, like a login screen that prevents people from getting into your stuff, then ultimately I have a whole bunch of Underground Nexus like servers running around in my location. So if you take a look at them, they have little login pages. But if someone else were to just like come over to this URL and I have this just a URL out there, anyone can just connect to this system and come in here and start trying to figure out what this password is right here. Have mercy if I enter in this password and someone's now just like here, they can then be in my environment and do little takeovers of my environment if I'm not using things in a secure way. So there's a lot of security involved with with Traefik, because you want to make sure that resources might be available to, like, let's say that I have a classroom and I'm trying to serve 100 students, 200 students, 1,000 students, right? If I just give all of them just plain URLs, someone could even just forget, the wrong URL, and if it doesn't have anything protecting it and they can just come in here and see what anyone else was doing at that URL, then it damages security things and it creates problems. So instead, let's say that someone wanted to come over here and try to take over my session. Well, now they can't just take over your session because you can put a little protection domain over even, say, one of these desktops. So if I were to log into this, which I'm not going to log into this one in particular, I'm just going to kind of talk about the theme. If I were to just log into this, then it's just going to give me another one of these desktops, but it's a secured one instead of me just going straight into the Underground Nexus straight from port 1000, which there are ways to protect it. You can actually, like if you're using Docker Desktop or different things, or like your local machine, you can turn off external port traffic so that your system, because there's Windows firewall, Apple has its own firewall, laptops have firewalls. If you're developing with the Underground Nexus, you can just say, hey, firewall, I don't want the Underground Nexus to be accessible away from my local machine that's running it. Or if you're behind a firewalled environment like I am, I'm behind a firewalled environment, then I don't necessarily need to have the same level of security measures because I have a firewall protecting me from other people just swooping into my stuff, basically. So anyways, if we then get into what's one of the big differences that we see between this thing with the login here, where was it? Here we go. You'll notice that instead of having like an IP address, if we look at the top here, we have a domain. And you can actually try to go to this domain on the World Wide Web. We actually own this domain, and you'll notice that you can't get access to this domain, but there is a way to get access to this domain, because you can see that my system here can see this domain, and I did actually make this domain so that others can set it up, and we're going to learn how to set up a hidden domain that you can control. And what this is called is it's called load balancing with DNS Zones. It's maybe a little confusing, but there are other reasons for that. We'll get into that. So notice that it says undergroundops.me. It's got like workbench.undergroundops.me. If we take a look in here and I do like a control F to find something, I say ops.me, we can clearly see that we have an undergroundops.me hiding in here. And we also have an API.undergroundops.me. And if we take a look for passwords in here, notice that this has a default password. Now, this default password is something that is just out there, so I would recommend changing this default password if you're using this. One of these days, I will go through the process of teaching how to use this password hashing string. This gets into like some really basic cryptography. This isn't even advanced cryptography, but if you've never done any cryptography, that could be a little confusing. So what I would say is if you really want to get into using this to test it first, it might make sense to, when you're using this, to add a little comment hash right here to temporarily disable the password while testing this. Otherwise, if you're trying to test with Traefik API, then it's going to bark at you and be like, hey, now you need to enter in the, well, you could just use the default password information too if you don't know what I'm talking about, like this idea of commenting this. So if you're just like, I just want to learn how to run an existing YAML file, just know that the default password to this thing is right here so that you can actually test it and you're not just like, oh my gosh, what is this? I can't even test this resource. So what it will look like if you get this running, depends on how many services you have running inside of this thing, but you will see however many services you have running in this environment. We can sit here and click on Explore, and you can see that we have a series of domains being load balanced, right? Now, one of those domains being load balanced is our workbench.undergroundops.me, which we can see, oh my gosh, there's so many of these things. So here we go, it's this one. We can see that there is an HTTP undergroundops.me item hanging out here. And we can then see that there's an HTTPS. The way that this is designed is it's designed to forward your HTTP into HTTPS traffic. So it also encrypts your traffic as it's being load balanced, because encryption is important. So one of the benefits of this then also is, let's say that you're looking at this right here. For anyone who knows the difference between like HTTP, HTTPS, all that good stuff, you're talking about like certs, notice that this gives the little thing. It says this is not secure, and it's barking at us and telling us these things. This is HTTP, which means that this is a non-encrypted, I guess, channel. What you're doing inside the Nexus has different input versus like what your connection here is, but it just means that this traffic is not encrypted. And so if you're not using a firewall or certain things like that, or something to encrypt your traffic, or something to manage the port management so that your data doesn't leak, then you're going to be in trouble. So here, not only do we have password protection, but we have HTTPS encryption, which you can see up here at the top where it says HTTPS. So if you one of the benefits of this is that it just forces all of your traffic to forcibly be encrypted. There are tools like, if you use Brave browser or different kinds of browsers and things like that, there's different things like HTTPS everywhere. If you ever Google HTTPS everywhere, that's effectively what these tools kind of do. So if you were to ever take a look at like HTTPS everywhere, it already exists in things like Brave browser. And what this does is whenever it does the same thing that what this little thing's doing here is, whenever HTTP traffic is available, then HTTPS everywhere says, hey now, I'm going to forcibly flip you over to the HTTPS version of whatever you're load balancing. So this kind of goes back to value of load balancers, is you can force encryption on things more easily with a load balancer. And when you're just developing, or you're just testing, or you're working on a single system, this doesn't really matter. If you're just spinning up the Nexus and you're not clustering, you're not running it on like 20 different systems, set up your local firewall to not let external traffic see port 1000. There you go. That's way easier than load balancing. And load balancing at that point is only for education purposes if you do not have a need or interest for scale or scaling your Underground Nexus. And the Underground Nexus can scale up to 5,000 nodes. That's crazy. Probably more than that, because it has both Kubernetes and Docker. So you can scale, I believe, at least 5,000 with the Kubernetes instance in here, and then another, I don't know how many, maybe another 5,000 with Docker. So you can do some crazy stuff. But anyways, load balancing makes it so that when you are starting to work with multiple systems, you can do more. Now, if you're wondering how to add additional services like the desktop to have an HTTPS desktop, because the default desktop that the Nexus launches on is designed for local use for the most part, it's not really designed for load balancing, there is a workbench that we did build that is designed for load balancing, that's built with the Traefik API kit, that has this login here that you see right here. It lives here so that you can choose, like, maybe you do want to set up a scalable service. This is what you would then use to distribute workstations to multiple people and to multiple individuals or however have you. And then you can even share your data, because one of the important things about setting up multiple systems is if you do start scaling and you say, hey, I want this one Nexus environment to serve 100 people, whether you have 100 developers working on the same project and they're like engineering satellites and FPGA or something along those lines. It's kind of built for engineering, just whatever. It's cloud native engineering resource. Or if you're trying to teach people how to build FPGA or load balancing or cloud native or cloud or whatever you want, then you can also make it to where you are able to use what's called an S3 bucket. We have something called the CyberLife Torpedo, which we will take a look at lightly we won't be spending as much time on that today. So in a later time, we'll talk about how to use load balancing. If we take a look in this Nexus bucket, speaking of buckets, we have this thing that says S3 torpedo. And the thing about the S3 torpedo is it allows you to make data available to your load balanced items so that they can have a central location of shared data. That's the purpose of the S3 torpedo, aka the CyberLife torpedo, and the Nexus bucket is basically where you access that resource. So this is kind of like a little cloud folder, this one that says Nexus bucket with a little lock on it. If we take a look at any of these clients, you'll notice there's a Nexus bucket here. If we open any of these Nexus buckets, they all have this workbench file, and we can take a look at any of them. It doesn't really matter which one. There's this Nexus bucket on all of them. Every single one of them has a Nexus bucket. They all have unique data, but they also all have the ability to have shared resources controlled by the administrator who load balances these resources to people. So whoever's load balancing controls these resources, but interestingly enough, every single desktop that anyone uses that's being load balanced out to other people has their own unique persistent data for their own instance that's separate and isolated from everyone else's, including its own DNS zone. So this is where it gets really crazy, because with the load balancing, we're talking about this domain, we're talking about all these things. We're going to have to learn about the DNS zoning, because if you don't know the DNS zoning, the Underground Nexus is designed to have forced DNS zoning as a security feature, and it's set up and configured by default, and it prevents people from doing DNS takeovers on your scalable resources, because when you have scalable resources, have mercy if you have someone who can figure out how to do a DNS takeover. So we actually have the Underground Nexus pre-configured with unique and individual DNS zoning, however you want to structure it. So let me show you how that works so that we can see, like, okay, so we're going to get some load balanced things. And we're going to learn how to set up a load balanced domain on custom DNS zones. Now, first and foremost, the environment that I'm working from is what the Underground Nexus is packaged from. The Underground Nexus is a pre-configured data center so that you don't have to know all of the things that someone like me and my team and even Jermaine, like all of us had to go through the painful process of building the manual version of what the Underground Nexus is modeled after. And so all of our configurations that the Underground Nexus turns into software, it's like we got to have certain chips, we got to have certain things. The Underground Nexus can actually emulate hardware as well. It's a random thing, but it really is modeled after our own data center. So in the Underground Nexus that I'm running the stream from, I have, because you can actually run a bare metal Underground Nexus. One day I'll get into how to deploy a bare metal Underground Nexus. Now is not the time. But we have our environment load balanced from our bare metal Underground Nexus, and the way that what that looks like is you'll notice that if I try to access undergroundops.me from the wrong host, that's effectively, let's say, like a host that's not approved to this domain, I can come over here and say, let's just try to go to the domain. So I'm going to say undergroundops.me. I guess I'll put in my https:// If I try to run that, it's not going to be my friend. It's going to sit there and be like, no, this ain't right. This ain't right. Anyways, this is what happens. Because it's a hidden domain, it's a protected domain, and it's a domain for your Git code. If you don't know what Git code is, look up GIT. The Underground Nexus, well, I mean, it's from GitHub. So if you don't know what Git is, then that's another thing, but I would recommend learning a little more about Git. So going back to this, it's just not loading. We can clearly see that I'm doing things, it's not going to load. Underground Ops .me. But if I have one of these nodes, a Nexus node that does indeed have the environment configured, then I can just come in here and say undergroundops.me, and voila, it's going to just simply log into the load balanced environment. Now, what does this mean? It means that we can decide who should even have access to this environment, even beyond deploying a password. So the password's one thing, but like, someone has to also even figure out how in the world. So not only do they have to figure out the password to the domain if you're trying to protect it, but they also have to figure out how to even access or find the domain to begin with, because it's a hidden domain. It's something that you're not just going to stumble upon. And one of the things that we've done is we actually did buy the undergroundops.me domain. So if someone out in the World Wide Web, because if someone's like, well, what if someone takes like the master version of that? We actually also own it up in the public cloud lands, so that people can't do a takeover of that domain at all. It's just completely locked down. It's just a locked down hidden domain that we built, that we also will allow you to use for security purposes if you want to use our domain, or you can set up your own the same way. It's just one of those things. It's a hidden secure domain. So let's see. In terms of making this domain visible, one of the most important things is if we go over to the master portainer that everything runs from in our bare metal nexus, because this is a bare metal ecosystem and it's not in the containerized version of it. It works the same whether you run Nexus on bare metal or in the container version. Anyone who wants to run it on the bare metal version, that is actually a service. We can actually do that for you, but that costs $100 an hour, and Jermaine will do it for you. Actually, it would actually be fun. But anyways, it's just because there's a lot more expertise involved with bare metal when it comes to avoiding misconfigurations, and containers we can pre-configure so that misconfigurations are. We have all the control over the misconfigurations in a container versus someone's bare metal. That's just a reality. So that's why you're not going to just, and it takes like months. It takes months to set up like bare metal resources, depending on how you want to go about doing it. So anyways, if we take a look at the Traefik resource that we have that's been deployed that everyone's looking at, we can identify that in the stacks section in Portainer once it's been deployed. And take a look at this, and if I select Traefik, we can see however many systems it's running on. Right now I'm not running it on a whole lot of systems, but that's because I'm doing some maintenance. But one of the joys of cloud native is if you're doing maintenance, if you've taken down like 6 or 7 systems, which is what's going on in our environment right now, you can keep doing your stuff, because all you need is at least a few nodes or a couple nodes running until you finish doing maintenance or upgrades on all your other nodes, because there's no reason to go down when you have a whole bunch of nodes in your data center. But we can see here that we have different services here running. Some of them are replicated, but we can see that there's some GitLab instances. We can see that there, I want to say there's a Prometheus instance, maybe not. Anyways, we can see that there should be a workbench one. Here we go. So there's this one that says workbench. The workbench container is this one. That's a load balanced version of our workbench. Now, going back to how we build this, if we take a look at the containers in the Underground Nexus, we've got our inner DNS control, which is what we're going to be taking a look at from here on out to the end of this particular lesson. It's a pretty beefy lesson, so we're probably going to kind of just get through that and then call it for this one. But inner DNS control is something that lives inside of every single Nexus node, and that is a DNS zone that you can then independently control, manage, and configure per Nexus. It can be locked down by admins, or it can be made available to everyone It just kind of depends on how someone wants to define their scalable architecture. You can see here that we have a Kubernetes load balancer for Kubernetes, which is our Kubernetes server. And then we have the torpedo, which, going back to buckets, the torpedo is how we deliver data across load balanced structures. And you can also load balance the torpedo. It depends on how you want to do that structure and management for it too. There are a lot of different ways to manage that, but by default, the torpedo allows you to just simply make your data available to whoever you want, who's accessible over a network. And then there is a default network that lives inside of the Underground Nexus. So if you take a look at this, it has a specific network called the Inner Athena Network, which allows us to load balance resources outside of the Underground Nexus, while meanwhile the things that are a lot more interesting are these overlay networks that allow us to talk among our clusters, and we load balance across these items. So our load balancing is happening over our ingress networks, well, over the overlay networks, very specifically overlay networks. So then if we go back over to containers here, then this is inside of the Underground Nexus, this little dashboard. We can see that it also has a workbench item, but this workbench, when we're just using the Underground Nexus like this, it is this default desktop right here. And it's the one that's not encrypted here. It is not our encrypted workbench. So if we wanted to then make this available, let me go ahead and take a look at our inner DNS control. Now, if anyone's ever seen Pi-hole before, this probably doesn't look familiar. So let me show you what this normally looks like. Is if you're using everyone can have their DNS zones look however they want, but you can see that there's some traffic for me doing all of the different things that I've been doing to get prepared for this whole thing. You can see that there's some tools that I use on here, like Gitkraken, which is a default installed tool. You can see there's a whole bunch of activity from Gitkraken right now, just because we move a lot of Git with the Gitkraken tool. So I can also see if some of that Gitkraken activity of people messing with my Git, is that me? Is that someone else? Someone messing with my stuff? Pi-hole lets you see what's going on with your stuff. So if someone wants to try to come in here and start doing stuff on your Underground Nexus, by taking a look at the inner DNS control, you can see who's snooping and if someone's doing things that maybe they shouldn't be doing. So hopefully this is traffic that was your traffic, because if you go in here and it turns out that it's someone else, then they can be found out, because you have monitoring right away just upon launching the Underground Nexus. By default, it monitors itself, and it starts with DNS, because that's a very important thing these days. And one of the things that we run into in cloud are DNS takeovers, or things like we use resources like DDNS. Well, the problem with resources, for anyone who's ever heard of DDNS, some might think that DDNS is dead, some might think that DDNS is unsecure. It's not that it's dead or unsecure, it's just that you have to have a use case that makes sense for DDNS. And this resource that's automatically monitoring your DNS, if someone's messing with your DDNS resources, then you can identify that level of activity as well, because you can point routers that might be DDNS routers to use your Underground Nexus as DNS. So your Underground Nexus can actually be DNS for an entire home. And then if you don't like the way that it looks by default, you can change what it looks like. It's the same tool, it can look different. Just because it looks different doesn't mean it's a different tool. So let's be clear about that. Now, because this is the Underground Nexus that connects to undergroundops.me, let's take a look at why this works and why the other one doesn't work. If I take a scroll down, now these tags are all the same language on all Pi-holes, so you'll see what it looks like here, and you'll see what it looks like with the normal Pi-hole, but there's this thing that says local DNS. Local DNS is an interesting feature because we can click on this and we can take a look at DNS records and Cname records, which these are things that we can either automate into a build as a form of approval system, Or you can manually plug things in here. In this case, we're going to manually plug things in. If I click on this local DNS records, the top option here where my mouse is kind of behind my head, I don't know if anyone can actually see that, so let me see if anyone can see that. I might have to move my camera tile on the stream. I'll just make myself real small. There we go. Now it's not a problem. Actually, maybe I'll scroll a little bit. Maybe I'll make myself maybe not that tiny because that looks crazy. That's better. All right, so now you can kind of see the menus a little better. But I clicked on this thing that says local DNS and DNS records, and then lo and behold, it lets us add new domains. So we can add domains. So let's say that we know what the IP address of one of our domain hosts are, then we can come in here and plug in, hey, I want this undergroundops.me domain to be pointed at a specific IP address. And then maybe because of load balancing, the IP address might change. And so we might have to do things to make sure that, if that IP address changes, that's the thing. There are different things you can do. But anyways, if we then take a look at Cname Records, you can sit here and add subdomains. So if you wanted to then add, say, workbench.undergroundops.me, then you can say, to the undergroundops.me domain, I want to go to workbench.undergroundops.me. And then on top of that, we just make sure that they all are also password protected, because then someone might still find that, passwords. Passwords are a great thing. So then we can come over here and say, let's say that we want to add some of these hidden domains here. Then we can say, let's see. Let's just set it up on a normal Pi-hole. So we're going to do a walkthrough on one that is not set up, and we're going to go over to local DNS. You'll see it's really not too bad. We're going to say DNS records. And in our DNS records, we're going to just add our domain is undergroundops.me. Anyone may use this domain. You'll have to choose what your target IP address is or set up DNS reservations in your DHCP server, and believe it or not, the Pi-hole lets you use the Underground Nexus as a DHCP server. So if you don't actually have control over your own DHCP server, you can turn the Underground Nexus into your DHCP server and not worry about the fact of, because not everyone has control over the network that they're on. Maybe you're a student and you're in college using some random Wi-Fi. Have your own DNS server, your own DHCP server, even on someone else's stuff, so that you can have true control over your development space and your development network. It's actually a nice thing. So then we can add in our IP addresses, whatever that might be. Everyone's going to have different IP addresses. These IP addresses, you want to do things to make sure that if they are subject to change, that they don't necessarily change. And as long as it shows that it successfully made it into the list, then we can come in here and we can try to add a subdomain. So maybe I do want to create workbench. Workbench dot. Then we can come in here and add subdomains. Sometimes you have to update a resource, but we're going to just see if it works right away. It may or may not work right away. Doesn't really matter. I'll show you what to do if it doesn't. So it looks like this worked because it's giving us this warning, potential risk. Now, I know what's going on in my network, but if you're on an unsuspecting network, you don't know what's swimming around there. There's honeypots, there's security tools, there's all kinds of monitors, there's monitors on monitors. I have monitors that watch monitoring tools, and all, it's one of those things. Other companies do too. Someone who runs a business probably If they don't have those things, they should. But if it's your server and your infrastructure and your domain that you're connecting to, this is mostly saying if this isn't your server, you don't really know what's on the other side. It could be a Trojan, it could be some malware. I have malware on my network, not for other people, but if you're like some unsuspecting fool, I work in cybersecurity. I do malware research still to this day. It's one of those things that I do. And someone who's just like, haha, I'm just having a great time in someone else's network and I don't know who they are, and you stumble upon my malware, I don't feel bad for you. You should never have just been in my environment in the first place. So that's what that's there for. But if it's your environment and it's your nexus and it's your network, then you can just say accept the risk and continue, because that's your network. And then you can come in here and log into whatever the password that you set is. Once again, if you don't know what this password is, this one popping up here, if we go back to these files, if you've gotten far enough to run YAML files, if you don't know what a YAML file is or how to use Docker stack deploy, that's something to pay attention to, and I'll show at a high level how that works. But the password is this. It's this default user and password. Did I put the username? I need to make sure the username's in here. Maybe it's not. Oh. Well, I think I need to put what the default username is. No, it's here. The default username's admin. There we go. So just use admin as the default username, and the default password is !1. That is the default password. Change your default passwords. I strongly recommend that. Anyways, let's see. So if you're wondering how in the world do you deploy these things in the first place, these YAML files to deploy Traefik, you know, maybe the first thing that you just want to know how to do is use this command here. If you Google Docker stack deploy, this is what you'll want to Google, and you just use Docker stack deploy to deploy the YAML files. The Underground Nexus by default deploys itself in swarm mode. So you'll notice if you're using a system that's not in swarm mode, that stack deploy probably won't work. I could be wrong, but I'm pretty sure that stack deploy requires Docker swarm mode. So you can see here, I don't think you even need to use any of these other flags. No, not really. Like, you can literally just type stack deploy. It's good enough. You can use some of these other recommendations here if you want, but I'm pretty sure you can just say Docker stack deploy and then just make sure you have the YAML file. And because these files here are on a web location, you can actually use wget commands or curl commands. For those of you who don't know what wget or curl are, maybe look those commands up. But if you don't know what those things are, you might have a lot to learn before getting into load balancing. Load balancing is not beginner friendly. You're gonna get lost on a whole lot, because it's for working on scalable systems, and it's for scaling your services across scalable systems and scalable nodes, whether it's hybrid cloud, whether it's, we focus on cloud native because it's more agnostic. So you might have it running in AWS, you might have it running somewhere. I don't know where you have your stuff running. Everyone has their stuff running where they have their stuff running, and that's where it should be. So anyways, let's see. Let me cover it, like the last thing that's relevant to this, because it's always a lot of things. So now you know how to set up a hidden domain, and we have a video of it that folks can go back, you can review, you can see how that works. Then we also, one of the things that I want to talk about is the S3 bucket, because I would recommend considering learning how to load balance S3 resources and how to use S3 resources with your load balanced resources so that you can have what's called like uniform state, or just data that's highly available, so that you can have your buckets share data to everyone who's using your services, more or less. So if we go and take a look at what is going on? Let's see. We will figure out what IP address this is on. This is on 9001.25. Oh, I know it. Ports. Gotta love ports. Okay, so if we take a look at Minio, which, for those who are familiar with Portainer, you'll get familiar with Portainer if you're using the Underground Nexus to its potentials. The Portainer resource in here, which if you're wondering how I access all these little things, if we go straight very specifically to step 9, step 9 tells you how to access Portainer, Pi-hole, and the CyberLife torpedo. These URLs only work from inside the Underground Nexus. So if I try to access one of these, unless I randomly have this IP address on my network somewhere, like this is just not going to work at all. So if I close that and I go instead into the Underground Nexus and I punch in one of those URLs, the one that says that it's for the torpedo, the CyberLife torpedo, this is the URL for the CyberLife torpedo right here. And you see that we have a default user and password, especially if you're just testing these things locally. Then we can come in here and log in to our bucket. Goes back to Jermaine's bucket comparison, is amazing. You can start to set up like exactly that thing. It is kind of like the water bucket comparison because you can load balance these as well. So all of those principles, all of those concepts, you can actually go in here and take, say, like one of these other, like the workbench proxy YAML file here, and you can come in and just modify the image and the ports because this is just a template for load balancing. And then you can come in here and modify the subdomains because you can instead make, I don't know, whatever you want to call it. You could call it s3.undergroundops.me or torpedo.undergroundops.me or cyberlife.undergroundops.me. It doesn't really matter. Whatever you decide that you want to name that is entirely up to you. And so the benefit here with these buckets, if we then do create a bucket, we could make like a cloud share for cloud data. And we could just say, I don't know if it's case sensitive. We could just say create bucket. And all of a sudden, I have this bucket. And, or this file resource. And it lets me move files around so that I can make these files available everywhere that has access to this resource. And so I can then make the data in this bucket here available wherever I want it to be. It's basically like a NAS. So let's say that I wanted to just like upload a file or whatever, it doesn't really matter. Maybe I want to upload this entire folder, or maybe I just want to open this. And maybe I want to share this kimu.sh file. Maybe this is what I want to do. Maybe I just say, let's put that file up there. That sounds great. Or I guess you could upload a whole folder. It doesn't really matter. Whatever you're trying to put in here. Boom, now we have this file in here, and we can share this script with other people now. And this script, we just have to make sure that we, as the load balancers and the admins of the network, just network that over to the right person, right people. As long as we network or load balance this to the right people in the right places, then we can then just make our data universally available to everyone who's receiving the services. Like if we were teaching, or let's say that we had 100 developers and we wanted to give all of them their own lab developer space. There you go, boom, you can work with 100 developers right away. You can make a staged image for 100 developers, load balance it out to all 100, make sure that it has all the resources you want. And of course we do pre-add resources that are incredibly valuable for development because that's what the Underground Nexus is for and about. There's things like GitKraken and GitHub Desktop, and it even has Visual Studio Code. You can come in here and you can use tools like you can come in here and you can use tools like Git lens and a whole bunch of crazy things. I thought I had this set up with. Let's see. You can use code spaces, so you can come in here and say open a remote window, and then this even scales you into the cloud so that you can make your S3 work also shareable all the way up to GitHub code spaces. You can say things like, let's see, connect to a code space. You can see that I've got different code spaces here. So maybe you want to go ahead and just scale out to the cloud and start doing that. It's that easy to just now add more cores. So I'm adding 4 cores to my instance using cloud cores. So I'm adding 4 cloud cores to the Underground Nexus for development, and then I can load balance my work that I'm also load balancing, scaling more compute resources to the master host that I'm using here for my own dev space, and then I can have up to 100 other developers who are able to not only have their own Underground Nexus, but let's say that their systems don't have the power that they need to do the work that they need to do. We set up the CyberLife Torpedo so that they can get the data, we can share our script files, we can do whatever we're doing, but now maybe you just also need to make sure that they have access to all of their stuff. So maybe at that point it suddenly makes sense to just make sure that they can come in here, take a look at their Git resources. They can come in here and look at like the different changes, and I mean, it's, yeah, you come in here and do your work together. You can have your Docker file. This is the Docker file up in GitHub. So I am even able to modify the Underground Nexus with my own Underground Nexus pipeline, and this allows me to maintain and manage the Underground Nexus. This is it right here. And it also self-healing, so if I come in here actually and just go change all the wrong things, I have this set up to self-heal itself or self-correct itself if I do the wrong damage over my code space. Because if you want to centralize your control, give yourself maximum scale, give yourself extra power however you want, from cloud resources all the way down to your local resources. I mean, it's pretty crazy. You can load balance. So yeah, so even right here, we're using multiple hosts. We're running, you saw that I was showing all those services running with us load balancing our own workbench resources, multiple Underground Nexus instances running, some of them not load balanced in the neatest way in my environment, or at least in my dev space. But as you can see, it's really easy for me to test like different versions of the Underground Nexus, Underground Nexus on different hardware. You know, I can try all the things, and it's, you know, right here, this is easily like 7 different unique hosts all working together that we're all looking at right here. A whole bunch of Underground Nexuses, ultimately, all running inside of an Underground Nexus architecture, because we run a cloud-native DevSecOps service mesh is what that is. So this is DevSecOps and GitOps is what this is. So this is a DevSecOps and GitOps tool and resource for building cloud. And let me turn off my cloud container. So let's just stop the current code space. But you get the idea. You can do full-on development at scale. The whole, like, why do we care about load balancing? If you're a person who cares about scale, you care about load balancing. If you are a person who cares about scale and doesn't do the load balancing, there's someone else who's doing the load balancing. So even if you don't like the load balancing, someone has to care about the load balancing, even if it's not you. And then you can come in here and build custom access rules for your distributed data, because, you know, if you are setting up things like, you know, we just set up a script right here that's living in this bucket. You can see what the usage of it is. You can manage the thing. You can fully audit it. So I know I was just like a lot of information to the face, and we just sort of like ran through it like crazy people, or at least I did. So you'll probably have to watch this again, Jermaine, because it's a lot of information. But what questions do you have after all that?
I think for me, I understand a lot of it. Like now just seeing like the local DNS set up through Pi-hole. Now, there's something that I would like to find out from you about the Pi-hole becoming your actual, like, Or are you saying the DHCP server?
Oh yeah,
That is something, and I guess you can do that within the Nexus, right?
that's right. Yes. So if you wanted to come into the Nexus here and set it up as a DHCP server, there are a lot of interesting local DNS configurations, and depending on how you set it up, it will be either more or less practical for different use cases. So you'll want to think about what your use case is, whether it's to be like a full network DNS or just like a specific zone. So if you want to say, hey DNS, notice that it has this option for DHCP here, but the first thing I'll say, depending on if you're trying to use it as a DHCP server, if you're trying to use it as a DHCP server, I would recommend using something that's not just allow local only. You can use these potentially dangerous options because the goal is to see more things. If you're using a firewall, the Underground Nexus firewalls this off if you're using, let's see, so if you're using, because I got this question earlier, is a good question. Folks have asked, what's the difference between the secure and the development pool? If you're using the development pool, the Underground Nexus's pie hole is firewalled away. So you won't be able to use it for like a full home DNS or DHCP server. No, it's the development one that's, sorry, let me start over because I don't want to confuse people. Ignore what I just said. The development version is for making it your entire home or entire network DHCP server and DNS server. So you do want to use the development one. The secure one is the one that, hence the word secure, because I was like firewall. Oh, I said this wrong. Yes, the one that is secure firewalls the pie hole away is the way that I'll put it. So if you are using, say, like this right here, and you're using the secure pool, then you don't really have to worry about the risks that come with this because it's firewalled off. And this, I'm pretty, yeah, it even says it makes sure that it's properly firewalled. So the secure one is properly firewalled for doing certain things. The development one, on the other hand, you do want to potentially choose this option if you're not trying to make it take over your entire network, because Pi-hole will take over your entire network depending on what you do, if you want it to or don't want it to. And then we have a bunch of options. One thing I do recommend doing if you're using it for home security and combining it with DHCP is using DNSSEC. That's a valuable resource. You can Google that for more details because we've been talking about a lot of things. And one thing I do recommend if you're trying to use it for an entire home network, if you want to make it go back to like a router or something along those lines, you can use conditional forwarding. You don't have to use conditional forwarding. That's particularly if you're trying to make it work with a specific DHCP server. If you are using the Pi-hole as the DHCP server, that's not really necessary, because then instead of doing that, you'd come over here and you'd select DHCP. And if you do enable this as a DHCP server, then you can come in here and you can do all of your leases here, which then I would recommend doing things like maybe you do want static IPs for certain resources, maybe not. But sometimes you do want to have static IP addresses. You'll notice that there are 2 resources in the Underground Nexus that have static IP addresses. If I were to go to one of these portainers in one of these, you will see that most of these IP addresses here are kind of just like 4, 2, 5, 7, and then you have like this one that's like 20.20, and then you have one that's like .30. These particular items actually have static IP addresses for various reasons, just because if you're trying to do something continuous with it, there's reasons for that. So that's all something that you might keep in mind if you are trying to put in a specific IP address and set up dedicated reservations that are unique to whatever is using this as a DHCP server. And then it does also have the API web interface, which is how you can get the Star Trek theme, if that's what you want. You can save that, and then you can be like Picard or Captain Kirk, I guess, or anyone from Star Trek. So there you go. I guess what are some other other thoughts while we're here?
Oh no. I think that's it for me. Like that was what I was very interested in.
Very cool. Well, it's a good session. My brain is slowly dying, but it's good. I feel like I just went through a whole lot real fast. I guess the last thing I'll say for people who are wondering about like how to learn more about Traefik, obviously there's a lot of trainings all over the internet. One thing I'm going to try to emphasize to people more and more these days is you'd be shocked at how much more value sometimes you'll get at using vendor documentation to try to figure out how to use a tool before Googling. What I run into is people will come over to the cloud native landscape and they'll be like, oh, I need to learn how to use all these tools. And then instead of just going to the vendor docs, what they'll do is they'll instead go straight to Google or YouTube. And so then they'll be like, how to use Envoy or how to use Rook, instead of just going to their website where you can. My recommendation always is to just come over here, see like what their website is. Okay, so we can see right here website. We're just going to go straight to their website. And then one of the reasons why vendor documentation is infinitely more valuable oftentimes than just going to blogs and things is blogs aren't always maintained. And you'll notice that a lot of these fast-moving technologies change so frequently that something that worked like 3 months ago suddenly might not work. And if you follow vendor docs, then they're always up to date because the vendor makes them. And you can spend a lot of time on Stack Overflow, but if you just go here first, for the sake of sanity, when trying to learn how to set up some of these things, then you'll find, let's see. So Traefik proxy is the one that we use, but let me just find, I guess it's not always clear. Oh, actually it is clear. It says get started. What am I talking about? It's right here. You just click get started. Boom. Vendor documentation, everyone. I don't know why I even spent any time trying to look through the menus when it was like literally front and center right there. So this is my recommended way of starting with a lot of the cloud native tools, because it might sound like it's like you're going and reading rocket science or something like that. You'd be shocked. It's really not as bad as you might think, because you're going to find much better diagrams than what I could whiteboard. I could sit there and try to be like, well, let me try to make some diagrams myself. I could make diagrams myself, but you're going to have a lot of value just coming in here and looking at their stuff right away. And they even go over the concepts. Like, I mean, you can then go and try to learn all these things. Now, let's say that you did read this and you're trying to like really get training from here. Then it's still valuable to go get training. It's still valuable to Google things. But just remember that the vendor docs are the location where everything's always up to date. But if you wanted to go over to YouTube and look for someone who's pretty good. Oh, hey look. Kubernetes from Zero to Hero. You can tell that I follow Tech World with Nana. That's who we're about to talk about, Traefik. And I don't even know if Nana watches my channel. Probably not. But what I will say is, it's not a promotion of any sort. It's just she just really knows her stuff. Just straight up. You want to go find a channel. There's other people who know their stuff too. So we could say, well, there's different ones. So that's Istio. I don't know if she has a Traefik one. Does she have a Traefik one?
That guy that you just had though at the top.
Up here? This one?
Digital Life. Yeah, he's
pretty really good. Oh, well, there you go. I just want everyone to find someone who's good. If Jermaine says they're good, I just haven't found this creator yet. That's the challenge with creators, is you don't know who's good and you don't necessarily know who's not good. It's not that people aren't good. It's just that sometimes with things like Traefik, it's hard to figure out like who are some people who are really good at explaining these things. Let me just mute this site. Let's see. Oh, it's already.
I'm pretty sure I believe he actually works with the Traefik team directly too.
Oh, that's super cool.
Yeah.
Look at that. You can learn all the stuff. That's amazing. And you notice that Portainer. Why do I use Portainer? A lot of people use Portainer. Portainer is very convenient. I don't know what else to say other than Portainer is very convenient. Some other interesting things about Traefik running from Portainer, which is pretty neat. If you're using services in Docker or Kubernetes, you can come into modify the service and it will update it universally. So you can come in here and you can change the networks, you can change the ports around. We got to get it up and running first. So, anyways.
And just to touch on some that Nato was saying, you know, it's one thing when you really want to test something out, but you're like, where do I test it and how do I test it at scale? Because a lot of this stuff is, the idea of it is to see how well does this work inside an actual environment, right? And I think for me, this is why I love the Nexus so much. Like, I get to use it as a learning tool, and at the same time, it's a platform that you actually can use for work, right? So it's both. So for Traefik, I've learned a lot of Traefik just messing around with it within the Nexus. And, you know, to me, that's what's great about it. So if you want to mess around with Traefik load balancing, you can actually spin up 3 Nexuses, right? And if you have enough hardware, or if you want to even just throw it in the cloud real quick just to test it, you have the option to. And that's what's so powerful.
Absolutely, yeah. It's 100%, because it's like, alternatively, like, what did we have to do to even build the Nexus? We had to get a whole bunch of bare metal. Like, I have at least, like, I don't even remember when I passed 60 servers, but we passed 60 servers at some point, and they're just like all over the place. I need to organize them at some point. And then you just end up losing track of all your nodes, and then it becomes chaos, and then you don't know what your name is. But the difference with the Nexus is you don't have to have all the bare metal laying around, because we basically took all of the stuff that is like mission critical from like any of our little server nodes, whether it's a little one or whether it's like the one next to me is as tall as my desk, literally. Like it's a very tall server. And then I have another server that's also about as tall as a desk that, you know, those ones are a lot beefier and stuff like that. And then we have a whole bunch of smaller dev boxes on top of that, stuff that we make. And the Raspberry Pi is cool too, and this works on the Raspberry Pi. And honestly, the Raspberry Pi is probably the lowest cost way to just get going with one of these if you want to build like a persistent server. It's just the minimum compatible hardware that we use. I'm trying to think, is there something... Raspberry Pi is probably the minimum. You can use like a Jetson Nano too. We actually need to do some work on making it compatible with the Jetson Nano. If you're using the Raspberry Pi, you do need to use the newest Raspberry Pi OS that just came out maybe a month ago. So if you're using an old Raspberry Pi operating system, you're going to have to set up a new Raspberry Pi operating system. And Ubuntu on Raspberry Pi, I don't think is 64-bit officially yet. I'm pretty sure it's 32-bit, even if you're using a 64-bit upgrade on the Pi Ubuntu. It's called what's called ARM v7, even if it's 64-bit. And true 64-bit ARM, like on a Raspberry Pi, on the new Raspberry Pi OS, is ARM v8. For those of you who are developers, that actually matters to you. For those of you who don't know what I'm talking about, I do need to say that for those who it matters for, because then they'll be like, oh, okay, I see. It has to be ARM v8. That's right, it has to be ARM v8. And you can get it with the newest Raspberry Pi OS. Very important to make that delineation for sanity. And then I am making an update for it to work on the Jetson Nano. It will work on the Jetson Xavier platform and the Jetson AGX Xavier platform, which is actually what we use. We use multiple Jetson AGX Xaviers for cloud native development. You can do things like pseudocore acceleration and develop AI with the Underground Nexus if you are using a pseudocore powered host. So we have some crazy things that we've done. So any last thoughts with this particular session, or anything else that you want to touch on last? That's kind of covered a lot.
That's it for me.
Cool. Good stuff. Well, thanks again for joining us, Jermaine, and we're going to continue learning some things. For those who are following Jermaine and I and learning the Underground Nexus, learning how to load balance, learning how to build clusters, Kubernetes clusters, swarm clusters that deploy Kubernetes clusters, whatever you're trying to do. And for those who are trying to build businesses, build business applications, and scale your businesses. If you're not trying to scale a business, you might not care about this. If you're like, how can I host 1,000 people in a server hosting environment somehow without $1 million? Underground Nexus. But if you're just trying to use one computer, if you're not trying to learn supercomputing or distributed computing or data science or AI or cybersecurity or something to those extents, Visual Studio Code installs on anything. If that's all if you're just trying to learn some Python, there you go. Start using Python on whatever you're using already, and you don't need the Underground Nexus. But the Underground Nexus is for people who want to get into the cloud practitioner and have actual cloud skills for building scalable infrastructures and working with supercomputers and building things like supply chains. So if you're not trying to build cloud supply chains and supercomputers and all those things, this might not be something that you care about or for you. Or if you're not trying to get into security, because if you're in security, you're securing these things, and if you don't know what you're securing, then you don't know what you don't know, and you don't know what misconfigurations you're even looking for to stop those first. Because you got to pen test this stuff. So if you're trying to learn how to pen test this stuff, you can learn how to pen test with this. And it actually has Kali Linux inside of it. It's the last thing that I'll show for now. If you are in here and you're logged into Portainer, you'll see this thing that says Athena 0. And we'll end on this. Athena 0 is a Kali Bleeding Edge repository that you can actually also use. Well, it contains the repository, connects to the Kali Bleeding Edge repository. But more importantly, it also runs Radare 2 inside of it. I don't remember the Radare commands, but it's in there. Jermaine, maybe one of these days I'll have you show people how Radare works if you want to do a Radare session.
All right.
If I spend time with it, I know how to use it because I used to use it a lot. It's been a while. But Jermaine's used Radare more recently. It's probably a little fresher.
Yeah. It's a pretty cool tool.
It's pretty sweet. So I guess I'll just type ls and everyone can see that we have Radare 2 right there. So if you're trying to get into deep forensics and you're trying to get into malware analysis and you're trying to go crazy, you can use the Underground Nexus for malware analysis and get crazy with it. So at scale at that. Hacking at scale. Anyways, I don't know if that's a good thing or a dangerous thing, but I just said something potentially terrifying and dangerous. So we better get off of here before we get accidentally hacking ourselves with all this crazy stuff. So thanks again, Jermaine. Appreciate you.